All right, this video is the first of two parts about solving differential equations. Usually this is an equation where you have a dy dx equals something, but it doesn't have to be dy dx. So in some recent AP problems from the last couple of years, there's been things like dh dt, or there was one that had like db dh. It really doesn't matter what the variables are. What matters is when you have a differential equation with two variables, you separate it by getting all of one variable on the left and all of the other variable on the right, including the dy dx. This is going to be kind of weird because we haven't ever separated this, but it is a fraction, so it follows the rules of math. The steps to solving a differential equation I put here. I'm not going to come back to this slide over and over, but just it's on your page, so take a look. Get all the y's on the left and x's on the right, or whatever the two variables are. Integrate both sides. You could put a plus c on both sides, but it kind of works out the same either way. So just for simplicity's sake, we usually just put it on the x side, and we'll get there. And then we'll have an initial condition, and we solve for y. These two steps are where you will spend most of your time and where most of your frustration will occur. But these two steps are the most important. So making sure that you get these right is going to usually account for about 60% of the points that you'll get will be the two first steps, which are honestly the two easier steps. So in our first example, we have dy dx is equal to x squared over y, and they give us an initial condition. Our first step is going to be to get all the y's on the left, so I'm going to multiply by y on both sides. And all the x's on the right. Well, x squared is already in the right, so what we're really doing is multiplying by dx on both sides. I know there's a lot of writing here, but basically what's happening is we end up with this. Y dy is equal to x squared dx. And it kind of doesn't matter if you show this work. You can probably, in fact, not show it. If you just eyeball this and think about cross-multiplying, it worked totally fine. So the nice part is that now we have an expression on the left that when integrated only has y's in it, and an expression on the right that when integrated only has x's in it. And that's what we're going to do. We're going to integrate the left, we're going to integrate the right. On the left side of this, the integral of y dy is 1/2 y squared. Normally we would put a plus c, but as I said, we're going to put it on the other side. The integral of x squared on this side is 1/3 x to the third plus c. Again, if you can get here, you've got usually about 60% of the points. This is the most important point. We now need to do two things. We need to solve for y, and we need to plug in our initial condition to find c. Now, it is really up to you when you do that, but I'm going to recommend you do it now. You don't have to, but I'm going to recommend that. If you put this in now, you'll get 1/2 times 5 squared is equal to 0, because x is 0, plus c. So c is equal to this is going to be 25 halves. You could write 12.5 if you wanted. And let's see, I'm gonna run out of space here. I'm gonna come over here. What we have now is 1/2 y squared is equal to 1/3 x cubed plus 25 halves. Trust me, it was easier to do it there than it will be later. We now need to get y by itself. There's going to be two steps here. Multiply both sides by 2. So after we do that, we're going to just have y squared is equal to 2/3 x cubed plus 25. And then finally square root, or you could write it as power of 1/2. So y is equal to square root of 2/3 x cubed plus 25, all inside of a square root. Technically, we do have to decide if it's plus or minus, but the way you decide that is really easy. You just look up here. When we plugged in a number, we only got positive, so this must be positive square root. So if that was negative, I would have put a minus there. It happens about half the time, so just keep your eye open for it. Next example. We're going to do the same thing. So I'm going to multiply y cubed on the left. That's going to give us y cubed dy. And then multiply dx on the right. That'll give us 6x dx. And then integrate. So when we integrate the left, we're going to get 1/4 y to the fourth. And then when we integrate the right, I know I'm doing this kind of fast, but the integrals here are easy. When we integrate the right, we get 3x squared, and then we put the plus c. Again, this is where I recommend you plug that in. This one's going to be a little bit uglier than the last one. When you plug in our initial condition, trying to get the right color. Let's see. 10 to the fourth is 1,000, and then 1,000 divided by 4 is 250. And then let's see, 3 times 3 squared is 27 plus c. So we get that c is equal to 223 when you solve for that. This one's actually nicer than most because it's a whole number, and we are definitely lucky for that. So this gives us 1/4 y to the fourth is equal to 3x squared plus 223. We now need to solve for y. Just like the last one, there's going to be 2 steps. First thing is to multiply by 4. That one gives us y to the fourth is equal to 12x squared plus 892 if you multiply 223 times 4, and then do power of 1/4 on both sides. So y is equal to 12x squared plus 892 to the 1/4. 1/4 is similar to square root, and that you have to decide plus or minus. But again, because that 10 is positive, that means it's a positive expression here. I didn't put an example in this video. Looking at the next one. Yeah, I don't think I put an example in this video where it comes out negative, but if that 10 was negative, then we would have put a negative there. That's the answer. Last example. This one I stole almost directly from an actual AP problem from, I think, 2017. So let's take a look. We need to get the y's on the left. That means we actually have to divide by this. I'm going to do 2 steps at once. When I divide by this, I don't actually want to write it as a fraction. Whoops. What I want to do is write it as a regular expression, y minus 1 to the negative 3, because we divide both sides by y minus 1 to the third, dy. And then just multiply by dx over there. The 2/3 could go on either side, but I always just leave it on the right. So this is not the ugliest thing in the world, but it's also not the nicest thing in the world. When we do the next step, we're going to integrate and integrate. And you can tell this one is just not going to be as nice on the left as the last 2 of them were. This is a simple chain rule, or a simple u substitution, I mean. The derivative of the inside there is just 1, so we can just do this as if it was y to the negative third. Negative 3 plus 1 is negative 2, so this is going to be negative 1/2 y minus 1 to the negative 2 is equal to, when you integrate that, you're going to get 1/3 x squared plus c. Now, that's our separate and integrate step. Usually you get about 60% of the points there. We do not have to do this now, but I'm going to recommend it. We're going to plug in our initial condition. When I say we don't have to do it now, you notice we're going to multiply by negative 2. You could do that right now. Multiply both sides by negative 2. Basically, that c would stay just c because it's some constant we don't know, and this will stay 1/3 x squared. Actually, why don't we do that? Let's multiply both sides by negative 2. This gives us y minus 1 to the negative 2 is equal to negative 2/3 x squared. And I'm still just going to write plus c. When you multiply an unknown constant by a number, it's still just an unknown constant. Which means we are plugging this in a different step. This is what I mean by saying, like, you kind of have a choice here. I just thought it'd be a little bit easier to not have that coefficient right there. When we plug in y of 1 equals 0, here's what we get. 0 minus 1, this is going to be negative 1 to the negative 2. And then, let's see, this is going to be negative 2/3 plus c. All right, so look, negative 1 to the negative 2 is 1 over negative 1 squared. So that's 1 over 1, so that's 1. So we've got 1 is equal to negative 2/3 plus c. Add 2/3 on both sides, we get c is equal to 5/3. Again, these are often pretty ugly like this. So we have y minus 1 to the negative 2 is equal to negative 2/3 x squared plus 5/3. So I plugged it back in at the level that I had plugged in the initial condition at. If I had done it from here, I would have gotten the same answer, but then I would have had to plug it in back to that level. All right, now we need to solve. I'm going to do both sides to the power of negative 1/2. Y minus 1 is equal to all that to the negative 1/2. This does mean 1 over square root, so technically we have to choose plus or minus, but again, not negative up there, so it'd just be plus. And then our last step would be to add 1. So our answer here, this is going to be ugly, is y is equal to that expression, negative 2/3 x squared plus 5/3 to the negative 1/2, with a big plus 1 at the end. Just to kind of say what this is, if you took the derivative of this, you would get that. Not quite in its exact form, but that's what you would get. Pretty ugly. This is about as bad as it's going to get for the rest of the year.